The first series which I am going to start is how to do the bare metal programming. In this series we will see how we can program the microcontroller bare metal. It means without using any IDE. First of all, what is the prerequisites of this session? So if you have already done some kind of microcontroller programming, okay, maybe Arduino or maybe some STM32 discovery board or nucleo board or maybe some Texas Instrument TIVA-C series. So any of these boards, if you have done the programming, then yeah, you are well and good to continue from here. Mainly you should know little bit about the C programming, okay, and memory mapping of the C programming, and then you need to know a little bit about the different softwares, basically the compiler, assembler, linker, what is the debugger, how we do the debugging. A little bit you need to know about the controller architecture. At the very core we have two kinds of architecture. So one is the Van Neumann architecture, one is the Harvard architecture. Then every controller is different from each other, although basic principle they follow these two architecture only. But yeah, a little bit these ideas you should have before starting this session. Basically, if you don't have the idea, then maybe you can go and check one or two basic videos you can watch on the C programming, on the C memory layout, and then the AVR microcontroller architecture or STM32 microcontroller architecture. After that we are well and good to go. Till now, if you have worked with any kind of IDE, it means integrated development environment. Mostly maybe you have worked with the Arduino. See, this is the Arduino IDE, and then this is your development board. Generally we call it evaluation module, where basically we test our software. So these are not meant to go into the production. These are the proof of concept. So whatever the project you are going to build, that will work properly or not, or how it will go at the initial stage. So you need to use the EVMs. If you have worked with the Arduino, then yeah, I would say it will be a little bit challenging for you to understand everything, since we are going to do it one series. But if you have worked with any of these IDEs, if you have worked with any ST microelectronics controller, STM32, or you have worked with the TI-TIVA series board, the Texas Instrument evaluation board, then it will be bit easy for you. You will be able to relate most of the thing. This is basically our nucleo board. This is from the ST microelectronics. This is mainly STM32, and this is their IDE. So this is basically QIDE. So next one is TIVA-C series board. This is from the TI, Texas Instrument. They also have their own IDE, that is the CCS Code Composer Studio. If you have worked off any of these controllers, then yeah, it will be relatively much easier for you instead of jumping from the Arduino. So IDE is basically a integrated development environment. It has everything, but yeah, they all are inside the one software. From a user's perspective, you will not be able to understand like what softwares are running in the background, what is happening in the background. Okay. When you are starting with the embedded system, using the IDE is fine, but when you go to the industry, when you start a job, mostly people don't use the IDE. Okay. They prefer to do each and every work which is happening inside the IDE individually. It has its own advantages and disadvantages, but yeah, advantages is major in the industry. We have these kind of boards based on this STM32 or TIVA-C series. I have here, I can show you TIVA-T series board. So this is basically the TIVA-C series board. Okay, you can check it online also. So this is a very basic development board. Okay, so it has some buttons and some LEDs are there, some pins are there to interact with your microcontroller. And this is one, I don't have the nucleo board, okay, but yeah, I have this another board, little cheaper than the nucleo discovery board. But yeah, it houses the almost every useful thing what we need. If you will see, this is our main controller. Okay, this is STM32F407. Okay, then we have the pins here, okay, to interact with the board. We have the pins, we have the battery also for the RTC real-time clock. We have some buttons also over here. You will see we have some buttons here. Okay, then we have some LEDs also here. This is the board which we are going to use to build our bare metal programming. In the disadvantage, I would say only one disadvantage is there, that for a simple work also you have to do a lots of coding and lot of configuration. I mean, it takes time to achieve a simple task also. And in the IDE, by the click of some button, buttons only. You can configure everything, you can generate the code, it will compile, it will build, and it will flash. So definitely the bare metal programming takes more time. It is not easy to follow up things there. So this is one disadvantage. Now what is the advantage? Advantage, like there are lots of advantages. The first advantage is when you do everything from scratch, so you have more control over your software. Second thing is related to the license, and mostly the IDEs which we use are not open source. If you are using something which is not open source, which is proprietary to some other company, it could lead to some financial this thing. You may need to share something, or I don't know, like those kind of things can happen. When you do everything from the scratch, then we have lots of open source software which we can use, and in that case we need not to worry about these things, licensing and proprietary and all these things. So mainly we use the GCC software to develop the bare metal embedded programming. If you have your own software, then you can optimize your software for your project. If you will use some IDE, so in the IDE all the software, all the stack is generic. It's not like optimized for some particular project or something like that. When we use the IDE, software also become bulky. Suppose if you have to do a very simple program, just a small blink program, so if you will use the IDE, it will unnecessarily generate lots of extra codes, lots of things it will generate. Although in many IDEs you can configure what you want, what you don't want, but still it will generate lots of extra code. I will show you. We will compare and we will see at the last why to generate the lots of extra code, why to waste our memory. Anyway, when we deal with the microcontroller, we have a very limited memory, right? We should be really cautious about the memory.